Hi again, welcome to my class. So today I will discuss about the graph of cosine and also the extension in the graphs of sine and cosine functions. Before that, let's continue the things from yesterday's class. Is that how amplitude can be found by taking difference of maximum and minimum value along y-axis, and the translation along y-axis can be found by using the arithmetic mean of those maximum and minimum points. So let's see how it is. So first of all, we shall talk about the amplitude. So here you can see the coefficient of x is 1. That means the amplitude must be 1. So you can see here that this is the maximum point that occurred at y equals to 1, and this is the minimum point that occurs at y equals to -1, and this is 0. So in order to talk about the amplitude, you can see the coefficient of x is 1. So amplitude of this function y equals to cos x is 1, and it will be given by the difference of the minimum point and the maximum point. So you can check it here that amplitude, if you denote this by a, then a is then maximum of y minus y minimum value divided by 2, and then it is y maximum is 1 minus y minimum is -1 divided by 2, and this is 1 minus minus plus, so 2 divided by 2 is 1. So amplitude in this case is 1 by using this formula. Now let's see if the amplitude is 3, because coefficient of the given periodic function is the amplitude actually. So amplitude is always the difference between the minimum and maximum point here. So from this equation, you can see that the amplitude is 3, but here also you can see the same. So here in this case, the maximum value is, can you guess it now? So this is, it was 1, now 2, and then this is 3, because the things have been multiplied by 3. So the amplitude in this case, because the highest point is 3 from either side of this x-axis, therefore amplitude is 3 just by observing the graph. But if you would like to apply this formula, so you can write amplitude equals to difference between maximum and minimum y. So y maximum minus y minimum, and is divided by 2. So y maximum, you can see this is 3, and y minimum, you can see this is -3. So this is -3, and this is 3. So that this is -3 and divided by 2. And you can see that 3 plus 3 is 6, divided by 2 is 3. So by using this formula, also you can find the amplitude. But why we use this formula? Actually, it will be needed when you find equation of the periodic function from the given. Now here you can see that I have added 3 to y equals to 3 cos x. That means by the rule of transformation, that is translation, if each and every point on this graph will move 3 steps up. All right. Therefore, I am taking one reference line as y equal to 3 to act as the x-axis here. So the graph of 3 cos x will show the same property about the line y equals to 3 instead of about the line y equals to 0, which is x-axis. All right. So let's see here, while translating this graph by 3 units of, or you can say the translation vector 0, 3, only the position of the graph has been changed. But if you think about the shape of the graph, there is no change in the shape of the graph. All right. So therefore, it's period. If you talk about, then period, and also here the amplitude we are talking of. So amplitude, both periods and amplitude won't change here. So if amplitude is 3 here, then amplitude is 3 at this point also. But if you would like to find this by using the formula, then you again use that to find amplitude. Amplitude equals to y max minus y min. That means y minimum value. That means we are talking about this maximum and the minimum value for 3x, 3 cos x plus 3, and divide by 2. So in the graph, if you read off, so here if you suppose this is minimum and this is also minimum point, so these are happening at y equal to 0. So minimum point is y equal to 0, and the maximum point you see here is 6. So y maximum is 6 and minus 0 over here. That means it is 0 divided by 2, and 6 divided by 2 is 3. So in this way also you can check that the amplitude is 3. All right. So why we are taking the difference of the maximum and minimum point in order to find the amplitude? Because if you slide this up or slide this down, every time the fluctuating limit along y-axis won't change. Okay. So this is the reason why we take difference of the maximum and minimum point in order to find the amplitude of this graph. Okay. And here one more speciality is that about this is that how to find this value. You can say this as C. Okay, that is the constant term, and which is in fact due to the translation vector 0, 3. So the constant term C we can write as maximum y max plus y min and divided by 2. Why it is? Because this sort of thing, when it is here, all right, then C value is definitely going to be 0. Okay, because on x-axis there is no translation at the beginning, so C equal to 0, and you can see that this is exactly at the midpoint of this maximum point and this minimum point. So if you take the y coordinate for this midpoint as maximum, in this case is, you can see 3, and you can see this is 3, this is at 3, this is 2, this is 1, and this is 3, and plus minimum value it is -2, so it is -3. So this is -3 over here, -3, and divided by 2, and this 2 have been cancelled out, so this is 0 by 2 equals to 0. All right, that means C value is 0 at this point, and also it is given by the midpoint between the maximum point and the minimum point. So the similar work we can do over here, that the value of C, because at this point it is shifted 3 units up, sometimes it is 1 unit up, sometimes 2 units down. So whatever is the number over here, you can see that every time C lies at the position where there is midpoint value for y coordinate. So in this case, let's check that whether or not by using this formula the value of C is 3. So here in this case, because now I'm talking of this graph, that means graph of this function. All right, so here you can see the maximum value as 6 and the minimum value, this is 0, and then this is divided by 2. So 6 divided by 2 is 3. Therefore, the value of C is 3. So note that always when you find amplitude, take the semi-difference of maximum and minimum y. And if you are going to find the value of this C, that is the translation vector along y-axis, then you can use the average of the maximum and minimum value along y-axis. Okay, guys, let's now discuss that how to sketch the graph of this periodic function. So this is y equals to 2 sine 2x plus 2 plus 2 Here you can see that 2 is the amplitude and plus 2 is the translation of the graph sine 2 sine 2x plus 2 by 2 units along y-axis. Okay. And when you take 2 common, then it is inside the bracket, this is x plus 1. That means in the graph of 2 sine 2x, if you put here plus 1, then according to the rule of transformation, the graph will shift 1 unit left along the y-axis. And if you find this is minus, then that many units, it shifts that many units towards right along the y-axis. Okay. So let's see that this is the amplitude, and you know the first of all you find the maximum and minimum value in this graph, that is our sketch sheet. So first of all, in order to find the maximum point and the minimum point within which the graph of this periodic function oscillates, so we'll see that first of all that you know amplitude is given by maximum y minus minimum y and divided by 2. All right. So you can see that here the amplitude is 2 given here. So this is 2 equals to y maximum minus y minimum, and then divided by 2, and then you will have one equation like y maximum minus y minimum. If you transpose this to the left and if you write towards the right side, and then it will be 2 times 2 is 4. So this is equation 1, you can say. And then another time you can see this is the translation of the function along y-axis, and this is in fact c. So c is given by, c means it is 2 again. So c is given by y maximum plus y minimum and whole thing divided by 2. So you will have another equation like y maximum plus y minimum equals to again 2. If you transpose towards this side, then that is going to be 4 again. So say this is equation 2. So if you add up these two equations, so you add these two equations, then in that case you can see that this is plus minimum value and this is minus minimum value. They got cancelled out. So we have one maximum and another maximum in equation 2. So it is 2 times of y maximum. So this is the case of algebra, and you can do at your convenient. And then to the right side, we have 4 plus 4 is 8. So y maximum value is 8 divided by 2 is 4. That means the maximum value that the curve takes in this graph will be 4. Now you take either equation 1 and equation 2. I'm taking equation 2. So from equation 2, you can see that. From equation 2, you can see that y minimum equals to 4 minus y maximum. And y maximum is 4. So it is 4 minus 4. That is 0. All right. So note that the graph's maximum value will be 4 and the minimum value will be 0. All right. And also note that as c equals to 2, that means we have to take one line of reference that passes through y equals to 2. That means the graph that has to show the property at this x-axis will be shown at the line y equals to the period for sine is 2 pi. So in general, period for sine of any coefficient times the given angle will be given by 2 pi by b. So keeping into mind this sort of thing, so in place of b you can see that here there is 2. So what you can do here, you can write here 2 pi by 2, and 2 and 2 they got cancelled out. So period of this graph should be pi. Graph is pi, that means the graph repeats repeats the same shape after every pi unit along x-axis. Now this is turn to draw the graph. There are different ways that you can make your work convenient. So at this time what I'm doing here, so this sort of table I have made for this only 2 sine 2x plus 2 only, and in fact here I'm talking of sine 2x only at this time because I have already done the work for this amplitude 2 and also the y shift 2. All right. So in this case, what I have done here, I have taken angle 2x. So the standard values of angle 2x are like this, so that x will be given by dividing each angle by 2. Then my values are like this. And if sine 0 at sine 2x is 0 at 0, then sine x is also 0 at 0. Sine 2x is also at 0 at 0. If 2x equals to pi by 2, that is sine 2x is maximum at 2x equals to pi by 2. So x equal to there is pi by 4. But along the x-axis, these are the values for x, not for 2x. Therefore, I have to think about plotting all these values of x along the x-axis, and then we'll see the corresponding value towards the corresponding values of sine 2x towards the y-axis, according to how we have taken this maximum and minimum value and also the period of this function. So here on this graph, let me see, one thing we are sure that maximum is 4 and minimum is 0. So the graph will not go beyond these two values. So that let's see here at 0 degrees. So first of all, I am working for, here you can see from 0 to pi minimum value, and then max. So I will start working from pi by 4 where it is maximum. All right. So let's see the graph where is maximum it is. So at pi by 4, the graph should be maximum. So maximum value is 4, but this is not pi by, but this is not only x, because if inside the bracket you can see there is +1, that means from each of this value you have to deduct -1. Okay, if this is plus, then you have to deduct. If this is minus, then you have to add to these values. So pi by 4 -1, if I do, then my value is minus 0.215. So minus 0.215 is here, and at this point the curve attains the maximum value. So I will note it down. This as the maximum point. Okay, over here, because maximum point is 4. And if I go to 0, then 0 will shift towards 0. It is 0 and 0 -1. Then 0 will shift towards -1. So that let me check where is -1. So this point is -1, but at -1, this point is -1. Okay, -1 is the, yes, so this is -1, and at -1 the curve attains the point 0, that is on x-axis, but x-axis is now here about y equals to 2. So 1, your graph will pass through this way. 1 means just above it. All right. Okay. Now after this we search for the minimum point. If that would be sine 2x, the minimum point would be at minus pi by 4. But at this time we have to deduct 1 from here. So minus pi by 4 -1, you can use calculator. This value is minus 1.79, where curve attains the minimum value, which is 0. So let's search where is 1.79. So this is 1.57 minus, and this is 2.4. So 1.79 is somewhere here. That means one part of graph, you can see it's working like this. One path is working like this. Okay. Now let's see what happens here. If you move towards right from this point, 4, y equals to 4. And this is the maximum point, and this is the minimum point we have already got in this side. Now we'll talk about towards the right side. So we have already worked up to pi by 4. Now at pi by 2, the curve again attains 0. That means it attains the point at y equals to 2 in this case, because of this value c equals to 2. So pi by 2 minus 1 is, you can see here, this is 0.570. So 0.570 is somewhere here. No, yes, somewhere here. So 0. It attains 0. So 0.570 is somewhere here. Yes, this is somewhere here, because this is 79 and this is 57 is somewhere here. And after that, the curve attains the minimum value at 3 pi by 4. But in this case, because of plus 1, we have to take minus 1. So that value is 1.357. So let's check where is it. So it must be somewhere here. This is 1.57, but we require 1.35 or 36. So it should be here. That means your curve will go like this. Okay, so let's see that here. The maximum is 4 and the minimum is 0. And then the curve will attain maximum point again over here. Then it will drop down to here and it will keep on going like this. Okay, so you can see up to here, I have taken the things with exact values, as far as this is correct. All right, so it is maximum value over here, and then your curve will repeat. Ready now. All right, and in order to check whether or not this graph is correct, you can go to a graphic software in order to check it, even though this is not allowed in your exam. Note that you are not allowed to take graphics calculator in your exam. But for your better practice, this is a good idea to use the graphic software in order to check whether your work is correct. First of all, I will take the graph of 2 sine 2, then x plus 1 and close the bracket. And after that, plus 2. All right, because I am compared with 2x and 2x plus 1, and then this is 2 sine 2x only, and then it is plus 2, and then you can see that what is difference between these two according to how I had taken the scale over here. I had taken the scale for sine 2x, but keeping it to mind the maximum point. If this is 1, then I will suppose that is maximum as 4. If this is -1, then I suppose this has minimum value. So if there will be plus 1 in x, then there will be one step shift to the, and same thing you can see in the graph also. If you compare these two values, this is pi by 4, and then in dark color, this is the original graph, and in the red color, this is the graph of the function 2 sine 2x plus 2. So when we have done plus 1 over here, it has shifted 1 unit to the left. So go to the calculator and check the difference between these two values. So your case of y equal to sine 2x plus 1 plus 2 should look like this. You can see that the maximum point 4 and the minimum point is 0. And this is the line y equals to 2, about which the same graph shows the property that it is supposed to show by the line y equals to 0, that is x-axis. Okay. So in the previous class, we discussed about the graph of sine. Now we'll see the graph of cos by using the Desmos graph here. So although we can test the graph in the graphic software, we have to do all this by hand, just like we did in sine graph. So here you can see that the maximum value of the cosine occurs at x equals to 0, that is 1, and the minimum values occurs at x equal to pi, that is -1. So amplitude for cos x is 1 over here. All right. And what about the period? So let me make this unlimited. You can see in the graph of cosine. So from here, maximum point up to here, it makes the half circle 180 degree. And from 180 degree to the maximum point, if you go, it makes 2 pi. That means it makes one complete cycle. And after this again, you can see this maximum and this minimum. So difference along x-axis between these 2 points will be 4 pi minus 2 pi over here. And here it will be 6 pi minus 2 pi. And similarly, if you go to the left, you'll have the same situation. That means the curve repeats after 2 pi along x-axis. Therefore, period for cos is also 2 pi. What happens if you write cos 2 times x? Just like we did in the sine graph that we have done manually by hand. So here, you note it down. The period is 2 pi now. So let me note this. So period was 2 pi before now. So here, if you talk about its period is 2 pi, then what would be the period of this graph in this case? So definitely this in the red color, and let's check. So here this point is 0 and this point is this is 0, and maximum occurs at 0 and minimum occurs at now pi by 2. Before it was pi, now minimum is at pi by 2 and maximum it is at pi again. So let's see here, from here to here it makes the half circle, and then from here to here it completes the circle. So the period for cos 2x is now reduced to pi. That means 0 to here. So one maximum to another maximum, this distance will be the period. And similarly from this distance pi and this is 2 pi, so 2 pi minus 1 is pi again. So period for this graph is now pi. Okay, then how it happened? Actually, it happened by the cos has period 2 pi, and then 2 pi, and then this 2 pi divided by 2 to make it pi mathematically. In this way you can see. And what happens, instead of cos x, if you write cos 3 times x, in that case, let's see that difference from this maximum to another maximum is 2 pi by 3. Okay, so the period of cos x is 2 pi, then period of cos 3x is 2 pi by 3, because you can see that from here, and from also minimum to minimum, if you check, it is pi by 3, and then this is pi. So difference of pi and pi by 3 is again 2 pi by 3. So in this case, the period for cos is now 2 pi by 3. And for example, if you would like to say remove this graph, cos 2x, then what has happened to the periods? So here you can see the expanded graph is for the graph for, sorry, not cos 2x, but cos x divided by 2, for example. All right, so this expanded curve is for the graph for cos x by 2. That means angle has been halved in this case. So let's check here. This is the maximum point, or you can take see about the maximum, minimum, both you can do it. So here, if I'm talking of cos x only, so you can see that the period is 2 pi, but if I'm talking of cos x by 2, the period is now from this maximum in the expanded graph to this maximum, the distance is 4 pi, so period has been doubled. And similarly, from this side, it is 0. And then this is negative 4 pi. So absolutely, this distance is also 4 pi. So in general, here the period for this period for cos x by 2 is now 4 pi. So in this case, you have seen that the period is 4 pi. How it happened actually? How did this happen? It happened because, so what we have seen actually, that the period is 2 pi, and when it is multiplied by half, then you divide this by half. So 2 pi by half is 4 pi. 4 pi. Okay. So here in this case, period was 2 pi, and then for cos 2 pi, the period has reduced by 2. So we divided by 2 here. For cos 3x, we divided by 3, and cos half x, we divided by half. So if the coefficient of x is the whole number, that means curve gets shrink along x-axis about origin or towards origin. And if, yes, and if x is multiplied by the number less than 1, then the curve gets expanded along origin about the x-axis. Okay, so this is the property that we have to note it down. So therefore, in general, you can say period of cosine can also be found by 2 pi by b. Okay, so note it down. If there is cos bx, then period for the cosine function is 2 pi divided by b. So let's now see the graph of cos x. And then what happens if you put graph of cos x? This is cos minus x. So what does it mean actually? X if turns into minus x, so towards right side of y-axis, the cos is positive. Towards left side of y-axis, the x is negative, x value is negative. So here cos minus x means we are reflecting the graph of cos x about line y-axis. So, but in this case, you saw that the graph of cos x in green color and the graph of minus cos x, these are the same, even though it has been reflected about y-axis. So you can see here this portion of the graph, if this is reflected about y-axis, then y-axis acts as a plane mirror. That is the line of reflection. So here in this case, on our side also, you will have the same image for the part between this and this. It's okay. And similarly, how does this part look like? So as y-axis has plane mirror, so its image will be like this. All right. So therefore, from graph, we can say that even though the cosine graph is reflected about y-axis, in that case, the graph looks the same. And another reason is that also, you know that cos minus theta equals to cos theta. So the graph also proves this sort of relation between cos minus theta and cos theta. So here in this case, we have cos x equals to cos minus x. Okay. Now, what if you reflect the graph about x-axis? X-axis means y becomes positive and negative about x-axis. When you go up, then y is positive. If you go down along y-axis from x, then it will be negative y, and therefore reflection about y-axis is in fact about x-axis in fact minus y. So minus y in this case is minus cos x. And what happens here? You can see here that if x-axis would be the line of reflection in this case, then image of this portion will look like this down to this x-axis, because all positive y became negative over here, but here all negative y became positive about the line y equal to 0, that is x-axis. So in this way, we can also observe the reflection of the cosine function about x-axis as well as about y-axis. And this sort of thing you need to try manually. So the graphic software is only for a reference. And then what happens here? Now let me check. It is cos x is like this. And if I see here for y equal to cos x, then amplitude is 1. You can see here the maximum point is +1 and the minimum point is -1. So difference between these 2 points is -1 by 2 is again 1. So amplitude is 1. What if you apply 3 to cos x? That means amplitude has been increased to 3. Upside is 3 and downside is -3 about y-axis. It's okay? And if you write 3 cos x and then plus 1, for example, so let me check through this. So what happens? The whole graph has been shifted 1 unit up about the line, and the same sort of property, instead of showing about origin, it will show about the line y equals to 1, because we have taken 1 step up. So here, in order to find the amplitude, you can see that neither amplitude nor the period has been changed, because there is no change in the shape of the graph. Only this graph has been translated 1 step up in this case. So you can see that again, if you would like to find the difference of this minimum point, and this minimum point is y coordinate is -2, and this y coordinate is maximum. At maximum point, the y coordinate is 4. So 4 minus -2 is 6, divided by 2 is 3. So amplitude is still 3 over here. Okay, so this way you can see it. And if you'd like to make some change here in x, for example, so if you are writing inside x, for example, it is -2, for example, it means you can see that the same graph. So it was the graph for 3 cos x and then plus 1. So you can see that as you have deducted 2 from x, The original graph, if you suppose this in the red color, has been shifted 2 units ahead, means two units towards positive x-axis. So you can see that this is 2 pi for this graph. Then because of -2, it has gone 2 unit right from here. So this is -2 pi, then this is definitely -2 pi plus 2. Okay, so -2 pi plus 2. Otherwise, you can check in calculator also that -2 pi and 2 units right means we have to add this. For the minus, we have to add. For the plus, we have to subtract. So +2, and this value is -4.28. So you can see that. Yes. So this portion of the graph has been shifted 2 units right because this is -2. And by the law of transformation of the graph, if this would be +2, for example, then shift will be 2 units left. Along x-axis of the graph 3 cos x plus 1. Okay, so you can compare like this here. So this is the original graph. From any point you can see here, this is the original graph in the red color. So this point is 2 pi, and -2 means 2 pi minus 2. You can check here. This is 2 pi minus 2 because there is +2 in the x. So this value is 4.28. So you can see over here that between these two, so this is for the original graph, this is 2 pi and -2 is 4.283 up to 3 significant decimal. All right. So in this way, we can do the similar work by hand also in the way that I had done for the sine equation. After doing all these works for both sine and cosine function, you have to note that the main points that the amplitude is given by, for the sine function I am talking, and also for the cosine function. So in order to find the amplitude from the graph, what you can do actually, it is y maximum minus y minimum divided by 2, and the translation or slide along y-axis will be given by y max. C means here this sort of thing along y-axis, that is translation along y-axis will be C, and that will be given by y maximum plus y minimum by 2. So while doing these two sort of thing, there will be no change in the amplitude, as well as there is no change in the period of the graph. Okay, so in sine graph, you have already seen that when does amplitude change and when does the period of sine or sine graph changes. Okay, so for cosine things, this is also the same way that we see in cosine graph. Only the thing is that sine is maximum at pi by 2, but cos is maximum at 0. But finding the method of finding amplitude as well as the translation vector along y-axis are the same, and also finding the period things for both the graphs of cosine as well as of sine are the same. Okay, guys. Lastly, we'll see that to find the equation of a periodic function from the graph or a sketch below. You can see that this is the graph of either of sine or cosine. It doesn't matter, but this is definitely not of tangent. This graph is not a tangent graph anyway. So in this case, by observation, you have to see the graph, and then from this graph or a sketch, you have to find what is the periodic equation. Okay, you can see in the scaling first of all here. So it is 2, 4 means 2 units equals to 1, another 2 units, this is 2, then this is 3, then this is 4, then 5 in between 4 and 6. So this way, so first of all, you have to understand how the scales are given there. And along the y-axis also you can see this is 0 and 2, so 2 units is 1, because here 4 units is 2, that means this is 1 and 2, in between 4 and 2 it is 3, and like this. So you have to see this gap. So 1 square unit equals to half, and the 2 square unit is 2 along both the axes. Okay, so first of all, in order to find the graph of this, so I'm assuming this is the graph of cosine function. So in general, I will consider one equation like this: y equals to a cos bx plus c and plus d. So here the translation along y-axis is represented by d. So if you get the values of a, b, c, and d from this graph, then you will have the periodic equation for this graph. So if you think of this, a is the amplitude and b is the translation of the graph along y-axis, either upside or downward of this x-axis. So you know that a can be found by using, if you would like to find a, then a will be given by y maximum minus y minimum and divided by 2. So y maximum is, you can see here the y maximum value is at 6. Okay, from here to here this is 6, so that is 6, and the y minimum value is here. So can you see this is y minimum is 2 here, so this is 2, and then it is divided by 2, so it is 4 divided 6 minus 2 is 4, divided by 2 is 2. So we have the value of a. Now what do you think about value of b and c? We'll see later. So first of all, let's see the value of d. So d will be given by d equals to, you can see that d means y maximum by plus y minimum divided by 2. So it is y maximum is 6 here, or you can see from the graph from here also you can see this is 6 because it is at 6, y equal to 6, and then plus y minimum is 2 again and divided by 2, so 8 by 2 is 4. So we have already the values of a and d. So let's note down your value of a is 2, and the value of b is, no, value of d is 4. Okay, now let's think of period now. What is the period of this graph? Period means b times x is going to be bx. So you know that period is equals to period of cos or sine is 2 pi, but here we are talking of cos bx. So therefore the period for cos bx will be equal to 2 pi by b. All right, now that is you can say that in general the period of this graph is 2 pi by b, Now let's see what is the period over here. So period means, if you are assuming this to be the cosine graph, so period means the distance between maximum to another maximum or minimum to another minimum. So here maximum points are obvious, so we take the reference of maximum point only. So here you can see that this is about 1, x equals to 1, so x equals to 1 over here. And here if you count, this is maximum at here, x equals to 13, and length between these 2 points will be the period of the graph. So period in this case is, how many counts here? From 1 to 13 is 13 minus 1, you can say, or just you count it, and then 13 minus 1 will be 12. That means period in this case is 12 equals to 2 pi by b, and therefore value of b is 2 pi over 12, that is 2 6 are 12, that means it is pi by 6. So we now have the value of d is here, and value of b also of level. So value of b we have got is, it is pi by 6. So we have all these values of level. Now we have to see that what should be the value of c actually. So if you are considering this as cos, okay, so cos has maximum value at x equals to 0, okay, 0 degree. So x is 0 point here. That means what happens here, it would be if this point would be over here, then this graph looks like as if it is shifted 1 unit right about this y-axis. So 1 unit right about that y-axis means, by the law of transformation, we know that the value of c must be -1. It's okay. Why -1? Because it has shifted 1 unit to the right. If it would have shifted 1 unit left, to make it exactly the cosine curve position at x equal to 0 degrees, in that case we write +1, but it is from this origin point, this sort of maximum point has been shifted 1 unit right. Therefore for 1 unit right we write -1. For 1 unit left, if it would be, we write +1 by the rule of transformation of graph along x-axis. So we now have available the value of c also. So value of c, we have now c equals to -1. So therefore this equation will become now y equals to a, value is 2, and cos b value is pi by 6, and in the bracket this is x, and c value is -1, and plus d value, you can see here d value is 4. Yes. So from the graph we saw that this is one of the equation for this curve. Okay, so it is 2 cos pi by 6 x minus 1 plus 4. Therefore, if you consider this graph to be of cosine function, the equation of our periodic function is like this. What if you consider that to be sine function? Sine function. So you know that the maximum of cosine occurs at x equal to 0, but maximum of sine occurs at x equals to pi by 2. So if you suppose this as the sine function, then in that case, what you have actually, you can see here, this is one step and this is another step, so that the graph looks like as if it was like this before. And like this before, and it has now been shifted 1 and 2 units left. So if you consider this to be the sine graph, what would be our equation? It is y equals to 2 cos, no, y equals to 2 sine pi by 6. So here x minus 1 for cos, because it has shifted one step right. But here, this graph, if you consider that to be sine, so sine has value 0 at 0 degree. So this is about 0 degree over here. So therefore, the sine seems to shift. How many steps left? It is 1 and 2 steps left. Therefore, we can write instead of x minus 1 for cos, but for sine here we can write x plus 2, because there is 2 units shift towards along 2 units shift towards left along x-axis. So it is plus 2 and plus 4. Here you saw that from transition from cosine to sine, there is change in only x, okay, but not in the amplitude, and also in the translation along y-axis. Okay, so that is the same thing. So we have the two equations from the same graph. So let's check whether or not these two equations give the same graph like this. So in the Desmos graph, let's go over there. Let's now check whether or not the same graph has both these periodic equations. So in order to check it, this is good idea that to go to the Desmos graph. So in the Desmos graph, let's see. So we have the same two equations, and you can see that for the cosine graph, we have graph like this, and also for the sine graph, we have the same graph. That means both these equations are appropriate equation or the correct equation for this given graph or a sketch. Okay, guys, next time we'll discuss about tangent functions and their graphs. So for now, thank you for your patience. See you in next class.